So here we go. 11.3b. This is the last set of notes for 11. Your test is only on Mod 11. It is not on 10 and 11. It's only on 11. Remember your quiz on Friday. Tomorrow is no calculator, but the test you can use a calculator on. Okay. What else was I going to say? Oh, this is still 11.3. So the homework assignment is on the same textbook page as last night's assignment. So if you find last night's assignment, look at the attachments on it on Google Classroom, and that's the textbook page you're using. Okay? Just documenting that. Okay, so 11.3b. This right here, if you can read where the hole punch is conveniently located, this would be like a problem we did yesterday, correct? Right there. Square root of x equals 5. What would we do to both sides? We would square both sides. And then that one we would have to check our answer. Why? Because the index is even. Okay? Now, one thing that we've learned through Mod 11 is the fact that square roots don't always look like square roots. They can look like other things too. What can they look like? A fractional exponent. So this is still technically a radical equation. It just doesn't look like a radical equation. Okay? So, step 1. Get the variable and its exponent alone on one side of the equation. Is my variable with its exponent alone on one side of the equation? Yes. Yes. Next thing I'm going to do, it says multiply by a reciprocal exponent on both sides of the equation. I don't really care for this term multiply by. I would say raise to a reciprocal exponent on both sides of the equation. So in other words, I'm going to raise both sides to a power, and the power that I'm going to use is the reciprocal of 1/2, which is 2 over 1. Why do I raise to 2 over 1? Well, that gives me x to the 1 times 2 is 2, 2 times 1 is 2, and what is 2 over 2? 1. Which is just x. So by raising it to the reciprocal, it cancels out. And then on the other side, 5 to the 2 over 1, that's really just 5 squared, right? Yes. And that is 25. Now, remember yesterday, to check my answer, I had to check my answer whenever there was an even index. How can I tell when I have fractional exponents if there's an even index? What part of the fraction tells me the index?
The denominator.
The denominator. So I need to check my answer whenever the denominator is even. That's what she says right here. Okay, if your denominator is even, check your answer. So, was my denominator even? So I have to go back to the original problem. The original problem said x to the 1/2 equals 5. And I'm saying that x is 25. And I can check it on my calculator if I need to. Does 25 to the 1/2 power equal 5? It does. That does equal 5. So my check is good. My answer is valid. Questions? That was pretty quick, wasn't it?
Yeah.
Okay. Ready for the next one?
Yeah.
Am I going to need to check my answer here?
No.
Why not?
It's odd.
My index is odd. What is my index?
5.
5, the denominator there. Now, going back to step 1, get the variable and its exponent alone. Is the variable and the exponent alone?
No.
What do I need to do?
Divide by 7.
That gives me x to the 3/5 power equals what?
8.
Now is the variable with the exponent alone.
Yes.
Okay? So I'm going to raise both sides to a power. What power am I going to raise them to?
5/3.
5/3, the reciprocal. Because that's going to get me 15 over 15, which is 1, which is what I want. Now I need to solve what 8 to the 5/3 power is. Now I can go to my calculator and I can actually calculate 8 to the 5/3 power. Or I can remember that this is really the cube root of 8 to the 5th power. What is the cube root of 8?
2.
To the 5th power? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 2 to the 5th power is 32. Now again, you can go here and just do 8 to the 5/3 if you know how to use your fraction button, and it'll calculate it for you. Did I need to check my answer?
No. No.
Nope, because my index was 5. Pretty easy? All right, let's go to the next one. Is my variable in the exponent alone?
Yes. No. Oh,
What do I need to do?
add 1.
Add 1. By the way, I should have asked this, but am I going to need to check my answer?
Yes.
Yes, because what's my index? 4. So let's see. X plus 2 to the 3/4 power is equal to what? 8. All right, is my variable in the exponent alone?
Yes.
That's kind of a deceiving question because there is a 2 that's not a variable. But this whole thing is the base, so my power term is alone. So now what am I going to do?
Multiply by the reciprocal.
Raise both sides to the 4/3 power, because that's the reciprocal, correct?
Yes.
That's going to cancel, leaving me with x plus 2. And what is 8 to the 4/3 power? We just solved 8 to the 5/3. Can you solve 8 to the 4/3?
16.
Because it's the cube root of 8
To the power 4.
to the 4th, or 2 to the 4th, and that's 16. So I'm almost to my answer. I'm going to subtract 2, and x equals 14. Did I need to check my answer?
Yes.
Yes. So I'm going to use my calculator to check. I'm going to go to 14 plus 2. That gives me 16. Raised to the 3/4 power is 8. Minus 1 is 7. It does check out. Now, I did that in 3 steps on my calculator. If I typed in the whole thing at once, I do need to put parentheses where there are parentheses in the problem. So I would have to do parentheses 14 plus 2, close my parentheses, to the 3/4 power minus 1, and I do get 7. Yes? Huh? That's your fraction button, the backwards L thing, right there between the 3 and the 4. That's from your fraction button. It's the button right here that says A, B over C. Okay? Get familiar with that button. It helps take off a lot of stress with fractions. Okay? Any questions on that one? Ready for the last one? All right, the last problem. Am I going to need to check my answer? Because I have an index of 3 and an index of 3. Now, I'm going to tell you something that's kind of interesting about this problem. This problem has a radical on both sides of the equal sign. Right? Because a fractional exponent is a radical. So this has a radical on both sides. This problem is almost exactly the same as this problem that we did yesterday. Do you see that?
Yeah.
You have a number out in front. So whatever exponent I'm going to use, I'm going to have to apply to that number out in front. So, is one of my radicals by itself?
Yes.
This one is, right? So I can raise both sides to the what power?
3/6.
3/2 power, right? Now over here, 2/3 and 3/2, those will cancel out, and I have 3x plus 1. Now, a big error that people make is, do you see how I just canceled these out with my pen? They'll go like this and say, oh, this is 4x plus 2. Yes, this cancels there, but I also have to raise the 4 to the 3/2 power also. So I cannot forget that step. Okay? What is 4 to the 3/2 power? 8. You guys are getting good at this. That's the square root of 4, which is 2 to the 3rd power, right? Square root of 4 to the 3rd power. That's where the 8 comes from. And then x plus 2 equals 3x plus 1. What am I going to do now? 8x plus 16 equals 3x plus 1. Am I going to be factoring anything? Nope, because there's no x squared, so let's get our x's together. So I have 5x plus 16 equals 1. Now what? Subtract 16. I'm running out of room, so I'm going to come up here. That gives me 5x equals negative 15. Divide by 5, and x has to equal negative 5. And I don't need to check my answer because the index was... Whoa! It's negative 3. Harry, I'm thinking I'm on top of things. Exactly, just making sure you're paying attention. So, negative 3 is my answer. I don't need to check it. Why? Because it was an odd index. Really quickly, on your homework, when you check your answers, one of the odd answers, I want to say it might be question number 5. In the back, it says like the answer is x equals 12. But that's wrong. The answer is actually x equals 32. So if you're checking your odd answers on your homework, I believe it's question 5. That should be the correct answer, not 12. The book makes mistakes sometimes on those. Okay? Happy studying.